learning, deep learning, applied signal, data analysis using expert systems, image processing, and biomedical signal processing. Let's give a big round of applause to welcome Professor Merit Naharan Mohanty. Welcome, sir. And now, to preside over this session, we have with us Professor Ashish Ranjan Das, Professor CUTM Paralakhemundi as chairperson, who will guide us through the discussions and ensure an engaging session. Give a big round of applause. Welcome, sir.
Very good morning to everyone. So today's talk is on quantum machine learning. As your conference is machine intelligence, so the intelligence lies on future. So till now, researchers as well as the academia used to work on the AI machine learning. For the future, if you will think that I cannot say innovation, if you will see the traditional part, the quantum was there. So that has been converted to quantum mechanics, and the science used to take as quantum information science. This makes in the different field that you can say as the quantum device for device people, that you can say the quantum machine learning for the AI and machine learning people or computer science people, that you can say quantum mechanics, that is also for the mechanical or civil people. And behind it, the mathematics is there that creates the multiplicity. If you think, I don't know whether you know or not the story about Lord Krishna, that makes his omnipresence. If you have heard the story of Krishna, the same Krishna used to be with his mother Jashoda. The same Krishna used to make mischievous things near the Jamuna river. The same Krishna used to take the makhan from different homes. You think the Krishna is one, but the part is to be subdivided and his presence in everywhere. So if you will see, the devotee can see, the mother can see, the lovers can see, and the society can see. So everyone can see at the same time. So that is the concept of quantum. That is the concept of quantum. So that is why I'm telling it's not innovation. Though nowadays researchers used to say that this is innovation, this was there. Only thing we used to find out this. So some part we will discuss here. That is the quantum machine learning. And for future AI, the same machine learning will be work done. So that is what is the future technology is quantum technology. So you see, as I told, the quantum mechanics, the scientists used to take from quantum mechanics, the computer science people used to take, that is information science, quantum information science. Both the combination we used to say in 21st as well as in the future century, that is quantum information science. This is the new science that we used to discover. We used to adopt from traditional or mythical stories, and those energies we want to employ for our computation. So that is what we can say from 20th century to the future century. So you see, if the computer science people or the devices people used to say, so they used to obey the Moore's law. The Moore's law was till 2018. Have you heard about Moore's law? Whatever the processor, Pentium processor or hexagonal processor or a Qualcomm processor, whatever the devices, those are based on the Moore's law. So that used to break. Now the principle used to break due to this quantumness. This quantumness. So that is the Moore's law used to crash once the quantum used to coming to the picture after 2018. So it was just started but not implemented. So that is why whenever researchers or the industrialists used to think that what next processor will be, how it can work, but that used to fail. That is Moore's law. So after onwards, the quantum technology used to be generated. So you can see the different companies like Google, IBM, Intel, D-Wave, Rigetti, IonQ. These big companies used to develop the processor. So that is what is your future. Even if for the researchers as well as the students, those who are working or those who want to work on it, so gradually they can achieve these companies by their development series. So this computing, initially the computation, that computation is taken part in machine learning. So at that time we can say that is the application across natural and social science, medicine. So that used to be considered as the quantum machine learning. And the application in autonomous vehicle, this is in your institute also. So that can be created with the quantum technology, drug design, material design, financial modeling, chemistry, even if for the data mining or big data. So the same concept, the same application, the same computing can be considered in this case so that the process will be faster as much as possible. That is in case of or in the measurement of nanoseconds. The process can be done with nanoseconds. But we need not to take whatever the real time we used to say or whatever the processing speed we used to say, that is as much as faster if we will adopt this quantum technology. So if you think this AI, so because machine learning or machine intelligence is artificial. As I have told you yesterday, the human intelligence, what you are thinking, not what you are doing. What you are thinking, you may do it, you may not do it. You may present here, you may think something else. You are sitting here because it is compulsion and attendance, but you are thinking something else. So that is quantum. That is quantum. And that is AI. That intelligence is transformed from human brain to the machine that used to called as the artificially. So that is why that is artificial intelligence or machine intelligence, and it is improve the productivity using the existing practices or the human employees or the industries. Almost all the sectors you can think, healthcare, transportation, business, and manufacturing. So it used to accelerate the research with this technology. So that means at that time we can say this as the quantum AI or quantum artificial intelligence. So AI, as I have told you, the devices people, the application specific integrated circuits, that is ASICs, quantum devices, the VLSI people, they are going through the ASICs and FPGA. They used to develop from the circuit to the processor. That may be the GPU, CPU, or any type of devices or processors, which are the core processors, are considered in case of AI. So what is the example of AI? That is robot. So robot is controlled by the microprocessor or microcontroller, that you can say, that used to automated. So artificial intelligence makes the devices automated. So automatically that used to work as the human being used to work. So you are also, nowadays you can see the chat GPT. Whatever the question or whatever the basic things, that immediately you used to go to your mobile or your computer, instead of Google, we are searching for the chat GPT. So instantly we are providing our questions and some of the answers are adapted, but those are not exactly the work. But the considerability it used to take as first time in the nature. Elpis, it was the in nature regarding the chat GPT, it has been considered. And this chat GPT is partially working on this quantum computing. So as we are giving the question, within some seconds we can get the answers. That means the database, the data mining is considered for this, and from those mining of data, the whatever the relevant answer that we can get. So if you will see, you can get the answer from ChatGPT, but the technology behind it is quantum or quantum computing. So applications, as I have told you, in defense, cryptography, that is cyber security, weather forecasting, teleportation. So many more things are there what we cannot imagine. So this application will take us to the coming future decades. So we are not trying to replace, as the Roshan of Google is the owner of that. He used to say, we are not trying to replace existing computer. The existing computers are not replaced. The replacing is the technology. That means we are talking about the speed up, as I have told you, that is in quantum speed. What we are thinking, that is quantum. We may get it, we may not get it. So based on the thought process, human thought process, if the processing can be done, if the processor can be developed, so immediately you can find those things and the computational tasks will be easy and implemented in the realistic case. So what is that quantum computer? If you think a quantum computer is a machine, same system that performs calculation based on quantum mechanics. I have told it, the thought process used to be converted to mathematics, and because it is dynamics, you can see that because it is the dynamics, the quantum state it used to consider. Quantum state it used to consider. If you have remembered from physics, that is the duality property of wave. The wave duality property. So that means in both the cases it used to present. So entanglement, we can consider with this entanglement, that means what we used to observe, we can observe this is up, but the same can be in the down, affected over other. What is the basic example? So similarly, superposition. So because one part is superimposed to another one. So the part is there and another part it is superimposing. So that in both the cases, if you are considering the 0 and 1, in both the cases, the presence is there. So that is how it is used to say the calculation is based on laws of quantum mechanics. That is the behavior of the particles in subatomic level. If you will go for the atomic structure, so many people, Feynman used to say that initially that it is nobody can understand. Initially, he thought nobody can understand. But in 1982, but in 1985, Deus developed the quantum turning machine. He used to say, no, yes, it can be understood, and some part, not fully, some part is implemented. Again, the development in 1994 by Peter Shor. He has the algorithm because this is of the Fibonacci number and the factorial. He has created for mathematics in 1994, and Grover finally another part is considered another algorithm. So in quantum algorithm, Shor has the contribution always, as well as Grover has the contribution. So some of only 3 or 4 algorithms are there, but we used to work now. So as I told, that is the subatomic level. If you have remembered the structure of atom, so there are the orbits across around the nucleus. So those are taken as K, L, M, N, that is in the atom orbits. If we will split the same orbit to subatomic level, the quantum levels are taken as S, P, D, F likewise. So the same was, if you will think, you can see here one electron is there, that is state 0. No outer orbit is there. Please be attentive because it is the main thing from physics only. So at that time we can take the example of light pulse with the frequency of lambda and the time interval is t. So basic t is taken, one is the excited state and another is the ground state. The nucleus is there, in the ground state one atom is there. The same used to excite to next state. Excite to next state. So in between which the energy, if you will think the Planck's concept with h, that is Planck's constant, this used to emit from one orbit to another orbit. That is with energy. H is equal to nu. Energy is equal to h nu or hf. So h is the Planck's constant, frequency, in that frequency it used to move from one orbit to another orbit. That used to make, that is the quantum state, and the energy is called as the quantum energy. So in classical bit, we can say that is 0 and 1. But whenever we are coming to the quantum bit, 0 has the presence, 1 has the presence. So if two things are there, we can take 1 plus 1 root over. The basic mathematics is there. If 8 particles are there, we can take 8 root over of 8. So that means here two states used to generate the new state. That is the quantum state. So that means in 0 there is 0, in 1 there is 1. Further, 0 is taken with 1, with 0, 0, 0, 1, 1, 0 and 1, 1. Similarly, 1 will be replaced and that can come to the 0. So 1, similarly, it will start from 0, 0, 0, 1, 1, 0, 1, 1. So both these states, because it is binary, so two numbers. If you think of 3, next you can say, if you can 3, so 0, 0, 0, then similarly it will take that much of states, 3 states, 2 to the power 3. So 0, 0, 0, 0, 0, 1, likewise up to 1, 1, 1. So here the bit, instead of the direct decimal or the binary digits, it used to consider as the quantum state. And the bits are called as quantum bits. So what is the computation that is based on this quantum bits? So how it can be taken? So that quantum bit, you can see the partially it is there. So it is not fully. So alpha 1, 0. So 0 state is again in 1. 1 state has again in 0. So that is why this part is given. So not it is 0, 1 in digital. So the one part is given as the straight line. And this alpha 1 and alpha 2 are the complex numbers. And that you can say that is alpha 1 square plus alpha 2 square is equal to 1. So if you think basically your complex number set, so that is basic idea, but not exactly the complex number state. This is that amplitude, that energy, that amount used to be as 0 and the rest of the amount is at 1. So that is why I told you, no, Krishna is at one place, but one part is with his mother, other part is with his lovers. So both the things, his presence is there. His presence is there, but that is not fully. So that is what is the quantum part. So as I have told you, the 3 cases. 3 cases means 2 to the power 3 is 8. So we will take the factor or scaling factor as 1 divided by root over of 8. So similarly 0, 0, 0 to 1, 1, 1. So all the bits it will cover with that alpha as 1 by root 2. The scaling factor, the amplitude as 1 by root 8. So you see now this state, that is the initial state as I have shown earlier, that is initial state. In the ground state, it is 0. Ground state means it is 0. Whenever it is excited to the exciting state, so it used to move. And both the places are occurred by that subatomic level. So 0 is there as well as 1 is there. This is what is the presence, that is omnipresence. So at 0, there is the bit, at 1, there is the bit. So 0 is considered at the ground level. Simultaneously, 0 is excitation level in one state. That is the beauty of this quantumness. So if you think of it, then you can solve immediately. It has been practically implemented, some of the part. It is not that the concept is new, it is also implemented. So now, as a whole, I am just telling, if you will take 0, 1, that is 2 to the power 1. If you will take 0, 1 and 0, 1, that is 2 to the power 2. If you will take 0, 1, 0, 1, 0, 1, 3 states, that is 2 to the power 3. Likewise, up to n or infinity you can take. Here I have taken the qubits of 300. So if the qubits are 1, then the total number will be 2. If the qubits or quantum bits are 300, then you can get 2 to the power 300. So now, otherwise if you think, that is nothing but the compression. That is nothing but the compression. Instead of storing such huge amount of data, we can compress the data without losing any information. That is lossless compression. You can take it with only 300 quantum bits. The process can be done, that is only with 300 bits. So that is what I have just given. All these distribution, if someone will work, then the mathematics perform gradually. Again, that is the data, we split it. So next question, how it can be retrieved? So in general, the n qubits will be taken to the power n minus 1, represents the numbers 0 through 2 to the power n minus 1, because it is used to start from 0. So it sounds good. So that means if you want to retrieve the data, then at that time, the second principle, that is superimposition. We need to superimpose the thing and we can retrieve our information without any loss. So another one is entanglement. Already I have told it. So in both these states, the superimposition will be there. So another thing, you can say the optical case. If you can give the thing, or nowadays you can think, forget about this figure, the mobile station, the signal used to come. So many detectors, your mobile, my mobile, everyone's mobile used to detect what is the frequency. So number of detectors can be taken. But the movement, the momentum of the wave used to arrive at each end. So each detector part, if the receiver part is there, so that can consider or detect the signal. So this is what is the basic mechanics. So superimposition, as I have told, again I am summarize. So simultaneously possess 2 or more values. So because 2 bits, I am telling simultaneously it will achieve 2 bits. If it is number of bits 100 or 200 or 1000, then it will achieve all those values. So that means that gives us the concept of omnipresence. Then entanglement, that means here it is there, in the next state it is there. So quantum states of 2 atoms. If 2 atoms we are considering, so correlated even though spatially separated. They are separated, it seems to be separated, but they are correlated. They are with those energy they used to consider. So this is the Einstein's concept, that is spooky action at the distance. Though it is at the distance, but the spooky action, that means here the presence is there and the next is the presence is there. Now you see the quantum bits, as I have told, the high or low. So it can be 0, the same can be 1. 0 and same can be 1. So you cannot say the definite answer. You cannot say the definite answer. So to be or not to be, that you cannot say. So nowadays some of the students used to say, no, yes, I may know, I may not know. So that is the same as the quantum state. So it can be 1, it can be 0. So the classical answer, to be or not to be, yes or no. But in state, it used to be. It may be to be, it may not be to be. It to be, it is also not to be. So that means either or both it can be taken. That is what the state of quantum computing or the quantum encoding. This is the part of encoding. So as I have told you, the source algorithm and the devices for that is had classical computation, and the search cases, the different algorithms as Gover's, and had classical computation. The elements you can take root over of n. So whatever the bits, that is 1 by root 2 or 1 by root 8 or 1 by root 300. So that is what is the, based on the elements we can take as the queries. So now implementation. If the device people are there, or computation people, how they used to implement it. You can take the unitary gates. Whatever the gates, how many gates, FPGA implementation, those they can take. So what is the quantum measures that can be taken? Simultaneously the classical. One side in the quantum, another side is the classical. Both used to come to the quantum programming, because the classical we are adopting since our childhood. So without taking that classical, we cannot go for the quantum. So both used to take. And instruction what to do. The next step we can go what to do. Then the compilation will be done. That is quantum compiler. And finally, we can get the quantum bit and retrieve the classical bit. That is what is the computation method. You will see these gates. This is basical gate, that is AND gate, and the operation is AND. So next, if you take as the quantum gate, so at that time they must be reversible. In standard gate, it is not reversible process. It is not reversible process. But in quantum gate, so initially it is taken as the gate as Hadamard gate. So that is why in the gate, if you will see some of the papers, you can see that is the H. H is the Hadamard gate. So that is the gate is implemented with the reversible process. The reversible process. So state 0 is given, like in the signal processing, one delay, next delay. So one state it used to achieve to the 0 to 1, again 1 to 0. So that means in between the part, entangle part, and the next it will come achieve to the next state. That is quantum state. So now for this, you can take as the NOT gate. Because if you will give NOT gate, 0 the resulted as 1. So NOT gate can be implemented with 2 Hadamard gates. This is the quantum gate, that is controlled NOT. That is initially I have shown that is only NOT, it is control NOT. So another line is there that for the controlling. Another line can be given as the control line. Similarly, control CCN. Control. So 2 control lines are given. So at that time we can get that is 3 bits. For single control bit, we can get 0, 0. For 2 control bits, we can take with the 3 outputs, that is A dash A, NOT gate, because it is NOT gate. So A output will be A NOT. B output will be B complement. C output will be C complement. So likewise, so A, B, C will be the complemented part, and we can implement the control NOT gate. This is the basic example for the NOT gate or quantum gate. So algorithms, as I have told, the algorithm depend on 3 things. So source algorithm, it is given as the modular arithmetic. Modular means XOR. Modular part we used to take. So simultaneously many data can be given, that is quantum parallelism. And if you will come to the spectral domain part, the Fourier transform has been converted to quantum Fourier transform, and all are based on the source algorithm. So what is that? How you need to prepare it? So load the input register. The steps also I am giving you. Load the input register with equally weighted, but it will be superimposed. Suppose 0 to 255. 0 to 255. So that is 0 to q minus 1. So now the total state is 256. So as I have told you, that is 1 by root over of n. So now there are 256 bits. So 1 by root over of 256. Then from 0 to 256, this is the quantum bit. So how many bits? 3 bits. So A is taken with the 3 bits. So this has the implementation in both the cases. Now the input register, this part you can take. Next the output is 0, 0, 0. So now the comma here denotes that the registers are entangled. As I have told you, A has entangled with 0. So this is 0, this is also 1. So now you apply, this is the basic mathematics. So whatever the quantum states we used to take, 1 over of q or root over of n. Another is the 0 to whatever the amount of states we used to take, q minus 1 or n minus 1. That weight is to be distributed among the quantum states exponentially. So e to the power 2 pi IAC divided by q. is the generalized source algorithm for the Fourier transform or quantum Fourier transform. This is the direct logic. We can implement it so that each part of the frequency, each part of the spectrum of the time domain signal that we can find out. The same case you can take up to 64, 2 to the power 64 or 256. So 0, 4, 8, likewise it is up to 256. It used to move. Same case, that is the source algorithm. So the algorithms till now, what I have studied since a long, because now I am working on this particular area, that is quantum computing, not exactly quantum computing, that is quantum machine learning. So the gate circuits, if the VLSI people used to consider, they may take the consider the two algorithms, that is source algorithm as well as Grover's algorithm. Or some of the cases, DEOS can be taken. And for the variational AI, for artificial intelligence cases, you can change in the DNN or the deep neural network or the convolutional neural network. So those models, you can change the autoencoder. You can change the autoencoder. So at the time of encoding, if the encoding is done encoding or quantum bits that can be encoded. Simultaneously, the number of things are there, the important information are taken from eigenvalues. So eigenvectors that we can consider. And finally, the classifier. There you can say the detector, there you can say the classification. And because what are the basic states? The information, then it is the features. So information is encoded through quantum encoders. Then the features will be the quantum features, and the classification technique all will be considered as the quantum classifier. That is in case of AI. That is in case of the machine intelligence. And another thing is annealing. For the civil or mechanical people, they can take, that is direct annealing or adiabatic evolution or QA, QOA. So coming to, I am not telling about the other mathematics and the civil mechanical things. I am just giving you the example based on the artificial intelligence or machine intelligence. If you think the basic one is supervised learning, unsupervised learning and reinforcement learning. The supervised learning, we can go for the problems regression and classification. If you will take the unsupervised learning, then that will be the generative models or autoencoders. But whenever we are going for the reinforcement learning, that is quick learning. That is quick learning. And that reinforcement learning will be converted to quantum reinforcement learning. That is for the machine learning. For the gate, you can just divide it in the Hilbert space. Based on the Hilbert space, you can use the Hadamard gates. So number of gates, so in between states it used to move for the processing, and finally you can get the output. Same case, the mathematics behind it and the approximation will be order of log C, log to the power C, that is 1 by delta, where C is less than 4 because two things are there. C is less than 4. The approximation is efficient, that requires the finite number of gates. So for two cases, we can consider 4 gates, and with this finite number of gates, we can implement the thing. Next, the encoder. So it is by Aspuru of IBM. They have already implemented it. It is not that. So hybrid classical quantum algorithm. So initially they used to define the optimization problem. Then the optimization problem, that means what amount of energy and how it is correlated. That is important thing. So that is the objective function. So energy must be less, correlation must be high. I'm just telling the problem exactly. Now the same is applying for the through the machine learning for the circuit design. So the quantum states they have created. So some of the modules for the different gates or different logics for the processor, because IBM processor they have taken, and finally with such gates, ADMAR gates, they used to implement it, and once it is added as the adder, and then it is taken as the decision. So in this case, we can say this part is the quantum processor unit, and other part we can go for the central processing unit. So initially it needs to be, as I have told, encoding part is important. So at the time of encoding, the quantum case is there. So in the quantum module, we can consider the problem, we can subdivide the problem, and finally it will be processed and passed through the processor. So once this quantum data, instead of basic data, once this quantum data used to pass to the processor, at that time you can say the processor has the ability to solve the process the problem and give us the output. So in that case, it will be more faster than the traditional processors. Similarly, another strategy for Perez Salinas is considered with the encoding. Either we can go for the direct encoding. This is the basic neural network. Whatever the inputs we used to give with the hidden layers, and finally from the decision we can get it. But here, this part is again subdivided into different states. So each part is processed, next part is processed, next part is processed, and gradually the processing will be there. So each bit is considered, and finally we can get as the classification result, that is the quantum classifier. Same case, next. So then the Garcia size and Ryu, as I have told, the reinforcement learning can be converted to quantum reinforcement learning or quantum machine learning. Even if they have used the variational circuit, that is variational encoder in case of deep learning case. So whatever the thing, that is the input in the middle stage. Now in this stage, it converts to the quantum states. It converts to the quantum states. So one used to consider as 3, as 0 is 0, 0, 0. So similarly, other part we used to take with those gates. And after the processing, we can get the mean square error. The error is to be evaluated because the target output is here. So input is there, target output is there, target minus the input, that we can obtain the error, and mean square error can be evaluated. This is regarding the deep learning. So the same, how it can be processed. So data encoding, I have told. The model is converted to this. In case of support vector machine, you can take the kernel as the quantum kernel, or anything you can take the model you can develop. So now measurement is taken as the output. That is the classical case. Now in this case, quantum case, these features are taken the expected value of the input. And those are the quantum states. And the same is to be functionized. And finally, we can obtain with the measurement that what amount is estimated. So if you will take the algorithms, the hybridization is better. So you can either consider the classical, or classical quantum, or quantum. So many things are there. I am not giving this. Next. Already told this. The applications you can take, again I am repeating, the least square fitting, the principal component analysis, the support vector machine, the deep learning, and quantum Boltzmann machine. So Boltzmann machine was the initial one, so that can be taken as considered as the quantum Boltzmann machine. the sampling state, leave it. The kernel case. As I have told, those PCA or those support vector machine, those can be considered as the quantum device, and the kernel will be connected or converted as the quantum kernel. So the new input will be the quantum input, and the training input will be considered as those two types, and the device used to process with this, and finally the model will predict based on the quantum kernel. This is the example. Detail I am not telling or explaining here. This is regarding the support vector machine. So the mathematical model behind it is a probable approximate control. The concept you can take, if somebody will work, then the concept they can take either the binary classification -1 or 1. So think that 0 and 1. So you can consider it may be dog, it may be a rat or squirrel or any other thing in different positions. So finally, if you the goal, so this is based on the statistical part, that is IID example, and we can take the probably approximate correct, that is PAC. So error with respect to target. The target is the human being, but different parts we have given. If we will just combine the parts, the part of these, then finally we may get some of the part or some of the without this part. So it learns with C, that means one fixed value, the algorithm can be given. So whatever the function that may belongs to, and then the probability part, the probability of that error is to be considered with the small change, that is delta or epsilon. Then finally it will approximate the whatever the correct answer is. This is another case of the satellite image, Earth observation. So different case, the annual crop is there, forest is there, Hibiscus vegetarian is there, highway. So different images are taken from the Eurosat image database. The database is Eurosat.
Sir, we need to conclude, sir.
Yes,
Sir,
yes.
time is very.
So now you can take this embedding part. So this is the last part, that is the quantum CNN. As I have told, the same case as the convolutional filter, pooling filter. So number of stages will be there. So input images, number of stages, and finally it will taken. So data encoding, data embedding, and finally it used to give this type of output shown is as the quantum. So for the binary classification, it is obtained as approximately 90%. Next. Back. Okay, leave it. So if you'll see the machine learning, with the quantum machine learning, it is conversion. Then the processing is called as the quantum information processing. So everything can be quantum if you will analyze with the bits how we used to take it. So thank you for your patience and attention. I hope this may work for some of the students as well as the researchers. Thank you very much.
Thank you, sir. That was truly an insightful session. A big thank you to our speakers for sharing their expertise and knowledge with us. Now, as a token of our appreciation and gratitude, we would like to felicitate our esteemed keynote speaker, Professor Mihir Narayan Mohanty, for sharing valuable insights with us today. I request Professor Ashish Ranjan Das to kindly come forward and present the token of appreciation to Professor Mihir Narayan Mohanty.
So before felicitating, I must say this topic is very new. This quantum computing with machine intelligence. And if you any students, computer science students, any mechanical students want to work on it, you can connect with sir. The topic is relevantly very new, so it may be difficult to understand. But once you work on it, I must thank sir, because the keynote should be like this. The keynote should be the new area where people should work. Thank you so much for this insightful talk. Thank you, sir.
Thank you, sir. Now I request Professor Sujata Chakravarti to felicitate Professor Ashish Ranjan Das. So I request, ma'am, can we please have you on the dais? Thank you, ma'am. Thank you, sir. Thank you, sir. We now move forward to our next keynote session, which will be conducted online. Let's welcome Professor Swagatam Das, ISI Kolkata, to deliver the keynote address. Give a huge round of applause, everyone.
Thank you. Am I audible to all of you? Can you hear me? Hello, am I audible?
Yes, sir. Yes, sir, you are audible.
Okay. So in next half an hour or 40 minutes, let me share my screen and I will talk mostly about the generative vision language models that underline the most latest developments in AI and ML field. So,
Sir, sorry to interrupt. Let me introduce to the audience, sir. Then you can.
okay.
Just a minute, sir. It is an absolute honor to introduce our distinguished keynote speaker for this session. Professor Swagatam Das is a professor at the Electronics and Communication Science Unit of the Indian Statistical Institute, Kolkata, and the professor in charge of the Computer and Communication Science Division for 2024 to 26. Previously, he served as professor and deputy director at the Institute for Advancing Intelligence, TCG CREST. He holds a PhD in engineering from Jadavpur University and specializes in deep learning and non-convex optimization. With over 400 research publications, he is the founding co-editor-in-chief of Swarm and Evolutionary Computation and an associate editor for several top-tier IEEE and Elsevier journals. Dr. Das has received over 33,000 citations and has been honored with the INAE Young Engineer Award and the Thomson Reuters Research Excellence India Citation Award. Give a huge round of applause again. Sir, you may take over the session now.
Thank you very much. And I apologize for not being able to present physically in this conference because I have been held up in several other meetings and other tasks. But anyway, nevertheless, in this session, let me try to introduce some of the very interesting developments in artificial intelligence landscape these days. First of all, what goes by the name of artificial intelligence around us, whatever we are looking and being amazed on a regular basis, like the latest Grok AI or DeepSeek, or before that, different types of ChatGPT-4, agentic AI, all these are based on machine learning. To be more exact, deep learning or deep neural networks. So in this slide, the first picture is a traditional machine learning cycle where data points are basically abstraction of different physical objects in terms of certain numbers sitting together. Such data points are coming, and then there is a human feature extractor or human intervened feature extraction technique where it is determined that what are the most informative discriminative features or numbers that summarize the characteristics or traits of these data points. Then such extracted features are fed into a classifier, which could be a very simple, shallow structured statistical model. And the classifier will put these input objects into various categories. This was the naivest, simplest machine learning pipeline. But as the nature of the data became more and more complicated, the human intervened feature engineering became so much non-effective for high resolution images, videos, ECG signals, EEG signals. These are all complicated pieces of data. So in those situations, the central question was how to most optimally represent a text document or an EEG signal or an ECG signal in terms of most important discriminative informative set of features, higher level features, which are close to human interpretation. Deep neural networks came into picture answering that query, and their biggest selling point is that they can sense the context of the machine learning job, like classification or regression, and according to the context, they can extract features which will represent the corresponding data items in most optimal manner. So if you change the context, the features that represent you will also change. I go to a bank, I ask for a loan, a file opens up in my name, and I start being specified in terms of my credit rating, CIBIL score, etc. I become a piece of data item. All financial parameters specify me: credit rating, my annual income, fixed deposit, CIBIL score, etc. But if the same person, me, if I go to a blood bank and try to become a potential blood donor, the blood bank starts specifying me in terms of completely different set of parameters. Whether I have blood glucose, what is my age, what is my blood pressure, whether I have thalassemia or any other blood-related disease. So you see, you change the context and everything that specifies you will also change. Deep neural networks, the reason behind their huge success is that they can sense the context from the cost function at the output of these neural architectures. And based on the context, they can actually learn the most suitable set of features that optimally represent the input data items for this specific purpose. And for these contributions, these two gentlemen, Professor John Hopfield on the left side and Prof. Geoff Hinton on the right side, they won the Nobel Prize in physics, though, in 2024 for these contributions of development of deep neural networks or deep neural systems. So now we are in an era where two deep inference models are quite popular. One is called the discriminative or predictive model, which actually is very happy to learn some sort of fairness or decision boundary between classes, between different classes in some abstract feature space. So in this picture on the right side, you can see all these yellow dots represent some cat's image in some abstract feature space. And all these blue dots represent some dog in some other abstract feature space. And the neural network, like a CNN, convolutional net, is very happy to learn this sort of linear or non-linear boundaries between the two classes, based on whether the point comes from the left side of the boundary or from the right side of the boundary. The neural network will tell you, the class of this point, whether it's a cat's image or it's a dog's image. On the other hand, in the most recent and happening area of generative AI, what we know as Gen AI, the primary emphasis is not to learn these decision boundaries, but to learn or estimate, better I say, the underlying spatial probability distribution from which the blue points denoting dogs' images might have been sampled or most likely to have been sampled. And similarly, another probability distribution from which these green points denoting the cat's images have been sampled. So if you look at the entire field of generative AI, it's like you have some example data items, like some images of cats, and you are assuming that these images are originating from an underlying multivariate probability distribution. You are then trying to estimate that multivariate probability distribution, and if you are successful to some extent to approximate that distribution, then in the next phase, you can estimate yourself from that distribution new points. That means new images which will look like camera clicked image of cats, but they are actually fake. So the last stage of generative AI is to sample from such approximated distributions points or create artificial images, artificial text, artificial video, whatnot. You must have heard of the term deep fake all around us. So that is the dangerous part of generative AI. But anyway, this is what generative AI mathematically resembles to. And now it has become an umbrella term for learning algorithms which can create or synthesize new content based on a prompt. And the result is often, you cannot distinguish the result from human text. The result can be incorrect, can be incomplete or biased, but there are ways of filtering such things. Applying this technology should therefore must be done under human control and oversight, at least for now. But if you look at this picture, this is the picture at the bottom of this slide. This is the general structure of any generative AI system. Your input is a prompt. Prompt means programming in human speakable language. So when I say I am prompting an AI model or I am prompting a generative AI system, that means I am writing natural language in plain English, plain Oriya, plain Hindi, plain Bengali. I am writing some instructions. And I am assuming that the large language model, which is the epitome of the modern generative AI models, will understand those instructions, and then as an output, it will create artificial text, code, image, audio, etc., etc. So prompting means giving instructions to your AI model or your generative machine learning model in your own language. This was a long cherished dream for the machine learnist, that I will communicate with my computer. Why I have to use C, C++, Java? Why not simple Bengali or simple Hindi or simple Oriya? This is very important. So that is where the generative AI models come. And for example, this is one of the first generation generative AI model, which involves two neural networks. One is the one is called generator, which takes random noise as input and converts them to matrices or images. On the other hand, the generator is like the student who is creating new and new images out of some random noise vectors, which are 50-dimensional or 100-dimensional vectors of random numbers. Another neural network is there. Every neural network is just like a function, y equal to f of x. Another neural network is there, which takes up these images from the output of the generator and scores them, ranks them. So this neural network, known as a discriminator, also has access to a repository of real-world images. It knows how the real-world images look like, just as your teacher is very much familiar with what is the international standard of research or writing essays, and according to the standard, the teacher gives you a feedback on your own writing. Similarly, the discriminator is aware of how the real-world images look like, and accordingly it treats or gives a score between 0 and 1 to the generated images. And based on that feedback, the generator improves its generation capability of newer and newer images, which are not carbon copy of the real-world images, but belong to the same category. So if you look at this training epochs of generative adversarial networks over 50 epochs, you see that starting from completely randomized pixels, GAN is learning how to arrange them to look like suitable handwritten digits. And this is how the GAN images evolved over time. So now you can see this lady on the right-hand side, all the details in her face, wrinkles, gray hairs, but the lady doesn't exist. This picture was never shot with a camera. Neither the picture, any of these pictures, these are human faces with gradually improving resolution. And these were never shot with any camera. These were all synthesized by generative adversarial networks. Then gradually we transgress to conditional generation, where you can constrain the output of the GAN. You may say, okay, I will generate only those images of human faces which have French cut or which have pairs of glasses. Or we will use intermediate ground truth images. Ground truth images will guide the generative network on what to actually generate. Okay. Then people thought, why generate only images? Why not additional pixels inside the image so that a low resolution image may convert into a high resolution image? From that thought came the super resolution GAN or SR-GAN. So you can see this low resolution picture on the left-hand side has become high resolution on the right-hand side. Then there came image-to-image style transfer through two GAN architectures in parallel. This was one of the biggest breakthroughs, because this idea of transferring the style of one image into second image, keeping the content of the second image as it is, later on get into, it intruded into the speech industry. People had vocal style transfer, like I may convert my voice. The content is mine. The main statements are all mine, but the voice texture may be from Mr. Amitabh Bachchan. And nowadays it is possible and very easy for this transferring the vocal style. Okay. This is one of our work where we are showing more abstract transfer of facial expression of one person or even one animal like a cat into several other animals like the dogs. Okay. So I'll skip some of this. State of the art. Hello? Hello? I can see some noise here. Hello. Am I audible? I mean, I can hear some noise at your end. Okay, now it's fine, I think. Okay.
Yes, sir, you are audible.
Okay, thank you. So the state of the art in image generative models are called diffusion models. What they do is they add, and diffusion models can generate stunningly realistic images. What they do is they add noise in steps into real world example images. Any generative AI model means you will show it lots of examples first, lots of real world examples of images, texts, etc. After imbibing those examples, these generative AI models will create their own images, own text, own video, etc., which are not copy from the real world, but which in category very similar to the real world example being shown. Diffusion models go on adding noise into the example images until the image is completely noisy. This is Gaussian isotropic noise. Then they go on removing the noise in steps by using denoising neural architectures like a denoising autoencoder or maybe an UNet until all the noises are removed and they got back the original image. They go through this forward diffusion and reverse diffusion process several times over all the images in the example set. So in the forward diffusion process, there is no learning, there is no neural architecture. The neural architectures are there when the noise is removed. Once these architectures are trained, then what happens is that they take up a completely noisy picture, complete noise. That means they sample a Gaussian noise in two-dimensional metric space. Then they denoise that picture by passing it through the previous neural architectures until the image becomes complete noise-free. And when it becomes completely noise-free, it becomes a new image of something like a new cat. If the example image set contains several cats, then after denoising, this complete noisy image will become a new cat, which looks like an original photorealistic cat, but that cat was not included in the real world example set. So this is the philosophy. The fine sculptures are already within the rock. What you need to do, this is a piece of rock. You need to chisel out the extra material, the superfluous material. And then you will get this sort of nice sculpture. Similarly, you need to root out the noise. Then you will get this sort of nice sculptures. Just one moment. I have a very important call to take.
Sir, we are not getting your voice.
Yes, just one moment. Somebody is knocking at my door, so I went to see that. Just a moment. Yeah, now it's fine. So, how we are making our progress through this landscape is very interesting. We started with traditional machine learning, where we had isolated single task learning. That means one machine learning model will be trained for one specific task. In a bank, you want to classify between fraudulent and genuine transactions. So you will train a random forest model or a gradient boosting model for this specific task. employ it, deploy it for that. And then once the need is finished, the model will be scrapped. For the second time in the same bank for a credit risk or loan default prediction, you will train another model from scratch. This is traditional task-specific use and throw ML. But human beings, what they do is, initially when they're employed somewhere at their early career stage, they get training to accomplish certain tasks. All of us do like that. Once the tasks are completed, they switch to either they get promoted or they switch to some other company, they get a new set of tasks. But what helps them is the previous experience of solving the previous tasks. They carry that experience with themselves. This is very similar to transfer learning, which became popular in machine learning area since 1990s. Transfer learning means you gather experience by learning to classify one particular type of data. Then when you are applied to a new situation, you are trying to classify a new type of data, the previous experience helps you. And you need little training, not again beginning from scratch. So if a big neural network learns how to demarcate between big trucks and small vehicles like scooties or tempos, then the same neural network in a forest surveillance system with little changes in its final layer, could be used for demarcating between big elephants and small deers, rabbits, etc. This is transfer learning. And finally, we are coming into the area of, from traditional ML to the area of foundation models. Whatever we see around us, like GPT series from OpenAI, Meta AI, DeepSeek, all these are called foundation models. These foundation models are huge neural networks trained on massive amount of external data, like the entire data of the internet, maybe Wikipedia, all essays in Wikipedia, all medical literatures in PubMed. So they're trained on this vast amount of external data. And then these massive neural networks can provide a variety of outputs. What output? They can fill in the blank for you. They can paraphrase a paragraph for you. They can, given a paragraph, they can answer the question answers from there and so on. Then you can actually fine-tune the model. That means you can customize the model for your specific use case by using enterprise or proprietary data, which is not available in the internet because this data is very specific to your company. And by changing the prompting technique, you can have the model serve your own purpose. Like ChatGPT is not a foundation model. It is just an interface. The foundation model under ChatGPT is basically GPT 3.5, GPT-4, 4.0, and now GPT 4.5. You can purchase some API, application program interface, from these models, and then you can probably modify it for your own company purpose. Suppose you want to create a new startup company which will be very good at modifying and writing CVs, biodatas for the job applicants. And you will use the job applicant is a young candidate. The candidate will provide in a very rough and haphazard manner the details of his or her career. Then the GPT or the generative model, the foundation model, it will arrange all those stuff in proper way and write down a wonderful CV, provide the PDF of the CV to the candidate. This is, if you want your foundation model to do that, you need to show it several examples of how to create CVs. That is the fine tuning, but you need not train it from scratch. That is beyond your limit. It already has several experience. Then it will perform, it will be customized for your purpose, and you will launch a product called CV GPT. And it is a reality, actually. Most of the startups in India work in that way. They customize or tailor-made such big foundation models for these purposes. So we are progressing from task-specific model to transfer learning to foundation models. And even in imaging side also, you can see this sort of foundation models called segment anything. Segment anything, or SAM, was just proposed in 2023. It's a foundation model for computer vision. So you give any image like this and you want to separate one cat, maybe the cat with the black ears. This is your input image. And you can just simply write a text prompt, cat with black ears. And this particular segment anything model will separate the cat, will segment the cat with the black ears. Okay. So as I said, the entire world is being taken with storm with the advent of the LLMs, or large language models. What are LLMs? LLMs are literally huge neural networks, foundation models, because they are trained on huge amount of internet-based text in almost in an unsupervised manner. And then they can actually serve or provide various outputs, from natural language processing tasks to your own domain-specific sentiment analysis to fill in the blanks to paraphrasing, everything they can do. And you must have seen all those stuff. So I will skip some of these slides because the time is gradually ending up. So LLMs, these are huge deep learning models, that means neural networks, having huge number of parameters trained in an unsupervised way on large volumes of text. For example, Pathways Language Model, or PaLM, is an LLM from Google. When PaLM was fine-tuned using medical data, you can see it became MedPaLM 2. You can upload chest X-ray images or similar images in MedPaLM 2, and it will write you down basically the findings from that image like a pathological expert, and also provide you the impression what these findings mean. At the heart of all LLMs, the neural architecture that is there is called transformer model. A transformer includes an encoder neural network and a decoder neural network. Encoder neural network takes the input strings or text sequences, converts all these words. If we assume word is the smallest atom of your sentence, so it converts all these words into floating point vectors in some vector space. These encoded vectors are then sampled by the decoder. The decoder has a huge vocabulary. The decoder, after writing a few words in the current sentence, what will be the next word? To understand that, the decoder learns the best probability distribution, softmax probability distribution on these different words in its vocabulary, and picks up that word which is most probable according to its learning to be included in the. Behind this transformer, what is new in here? Encoder and decoder architectures are there for a long time in deep learning. The new thing is actually the self-attention mechanism, which was, and this $1 trillion economy on large language models, the entire world is now after it. It started from this paper in NeurIPS, the Neural Information Processing Systems Conference 2017, and you will be proud to know that this paper is authored by its first author is an Indian, Ashish Vaswani. It's Vaswani's landmark work. And you can see this paper actually first proposed a mechanism called self-attention. In a nutshell, self-attention is a very nice way to quantize the association between different major keywords in a text. So if you go through this sentence, your eye and brain will pick up the major keywords like watching French show. You will not go into he, is, a. These are okay, pronouns, prepositions, etc. Now, watching has a higher attention. What is being watched? So the object of the verb is show. So watching should be highly correlated with show. And there should be a very low correlation between watching and French. So the neural network memorizes or mines, better I say, that means learns the correlation among or the association among the various major keywords in a big text, filtering out the minor keywords, etc. And based on such correlation, it can answer several questions from the text already fed into it, or complete the text, or paraphrase the text, etc., etc. That is basically the idea of this encoder-decoder model. And when attention came into market, it alone wiped out all the previous attempts like CNN, RNN, LSTM, etc. All the previous attempts to, I should say, handle big text sequences. Attention alone was sufficient. So you can remember this very cool Turkish shooting champion in the last games, Olympic Games or somewhere. Olympic Games, yeah. So ChatGPT is basically such a pre-trained transformer, which we call it maybe GPT 3.5, which is fine-tuned by using question-answer pairs from several human users. Pre-training means acquiring the general intelligence. Fine-tuning means channelizing or customizing that pre-trained model for serving your specific purpose. GPT 3.5 was a general purpose generative transformer, which was pre-trained on almost the entire internet text, billions of documents in the internet, on common NLP tasks. After that, when OpenAI thought it should become a chatbot, it provided question-answer pair examples and gave it a reward-punishment model. So if it can answer properly, it will get reward. If it answers wrongly, it will be punished. So this reward-punishment model came from, human users, lots of people who worked for OpenAI. What are the questions that common human users will ask this chatbot? Such questions and their answers were formulated by human users, fed into the GPT 3.5 to fine-tune it. And there was a reward-punishment model from the famous reinforcement learning paradigm. Okay, this was called reinforcement learning with human feedback, or RLHF. After this fine-tuning, GPT 3.5 became ready to answer questions from human users, and ChatGPT was launched. This was a cycle. Now, we are way ahead. We are talking about VLMs, or vision language models. In a vision language model, people use multimodal deep learning architectures that align and fuse visual and textual representations using cross-modal attention, shared latent space or embedding space. The idea is you will upload an image like this and you will ask several questions. You can ask, is one cat behind the other? This is basically an object localization question. And the model analyzes this picture, says, yes, one cat is behind the other in the image. The cat in the back is facing the camera while the cat in the front is facing away from the camera. Then zero-shot segmentation. Zero-shot means you are not giving any example, but you are asking, segment the striped cat. You didn't say how the striped cat looked like. The VLM, like GPT-4 or 4.0, these are VLMs, vision language models. It already understands, okay, both the cats are striped, so it segments both of them out. Zero-shot visual question answer, what is the breed of these cats? And they will ask, the cats in the image appear to be domestic short-haired cats. One-shot means you are giving some hint. One-shot learning with instructions. Striped cats are called tabby cats. So what is the breed of the cats? So it immediately understands, okay, these two cats are striped, so they must be tabby cats. This is just one snapshot of what VLM can do. VLM can do a variety of tasks. You can upload a meme and you can say, okay, sometimes I just look at pictures of the earth from space and I marvel how beautiful it all is. And GPT-4 explains that this meme is a joke that combines two unrelated things, picture of the earth from space and chicken nuggets. So the VLM already understood this picture is actually some chicken nuggets vaguely arranged in the form of world map. And it says so. Educational technology, learning technology, you can give a prompt to generate any image required for your teaching, like the image of human heart, and it generates that image so nicely and so on. Prompting, by the way, is the most important part of getting any LLM perform your task. You must give it effective, proper instruction. And you must be very seriously scrutinize the response it gives. So instead of just saying summarize this article, you should say more concise, more contextful instruction, like provide a concise summary of the main points in this news article about climate change. So you are perfectly specifying the context. One very good prompting, all of you I know must be using ChatGPT or similar things these days. You cannot escape it. If you want to have it solve some complicated math problem, which has several logical layers inside, you should, after the question, write this red prompt. Let's think step by step. This is the simplest, very popular prompting technique generating from this paper. Large language models are zero-shot reasoners. So this prompt will encourage the LLM to break the question into several small subsegments, solve these small segments one after another until the final answer is written. So large language models can be utilized very effectively in scientific research. They can provide, extract, summarize the relevant information from scientific literature. They can draft the research paper, grant proposals, outreach content. They can generate code examples, facilitate language translation, assist in experimental design. There is a huge, debate across IEEE, Springer, Elsevier regarding if somebody uses LLMs to create the content of a scientific paper, how should it be declared? Let me tell you, if you are using LLM to create your scientific content, if you have written the paragraph by yourself, you copy that paragraph to an LLM and ask it to, modify the paragraph or remove the grammatical errors from the paragraph. And the LLM does that, modifies all the grammar errors, etc. Then you need not declare it actually, because Grammarly is also backed up. I don't know how many of you use Grammarly to correct your grammatical errors. That is also backed up by an LLM. But if you ask the LLM, you are not writing anything. You are not uploading your writing, but you are asking the LLM, write me the related work section of this paper, this, specifying the paper. And the LLM writes down the related work section, adding some very interesting set of references, some of which may be ghost, because the LLM can make mistakes, fabricate answers called hallucination. So when the LLM does that, then you must declare all those portions in your write-up. You should delineate, okay, from this line to that line, these are authored by ChatGPT-4 or Meta AI. You must declare it clearly. But if you have written it and the LLM is correcting it, then you did not declare. This is just one piece of advice from this context. We are almost at the end, so I will skip all these things. DeepSeek actually is a very interesting structure of LLM, which puts much more emphasis on the reinforcement learning part. The idea is OpenAI or ChatGPT, these LLMs, they usually sit with the supervised fine-tuning part. It's more like when a little kid starts learning language, the kid doesn't sit with a huge dictionary with all words there. The kid starts learning language by interacting with the kid's parents, the family, and so on. through that interaction, the kid gathers the sense of language, and more interaction happens, the kid's vocabulary increases, the kid's application of proper words, the ability to apply proper words, correct words also increases, and this goes on. So DeepSeek usually uses two most important things. One is it doesn't create a huge neural architecture using all its parts simultaneously. It will activate only those parts of a huge architecture which are currently needed. This is called mixture of experts model. And then it is backed up by a wonderful reinforcement learning model, which doesn't use a costly model for its rewards, which learns the rewards from previous answers. This is known as the GRPO, or Group Relative Policy Optimization. As a result, DeepSeek has cut down the cost of building LLM drastically, and that was the reason why on 27 January 2025, the entire share market in US crashed. Now they are trying to cope up, mostly by banning DeepSeek from various countries. Grok AI will be very soon banned in India. I'm almost at the last of my presentation, so I will skip all these things. And just to let you know one thing, all these LLMs are biased. They're not free from various types of bias. That's why nowadays in AI audit systems, we must see whether the AI algorithms used by different companies are giving extra advantage to some specific demography. If I give this prompt to DALL-E 3, the image generation model within ChatGPT-4, 3 friends enjoying coffee at Starbucks, it creates this sort of a nice image. Okay, every time. Starbucks, coffee, 3 friends. But the problem is all the 3 friends are Western. They have white skin, they have silver blonde or platinum blonde. It will not at its own create any person from Asian continent to have coffee in the Starbucks, because the most of the training data comes from UK, USA, Europe, etc., heavily biased. Then when after some time, when I give this prompt, 3 Indian friends enjoying coffee at Starbucks without any reinforcement learning human feedback, no feedback on what you are generating is good or bad, it generates this type of picture. And well, this is fine. But the problem is, do we really expect Indian people in this sort of completely native dresses having coffee at Starbucks? Usually, no. After giving a lot of human feedback, it corrects this picture and makes it like this. This is also wrong, because this is a special situation, as if 3 friends are going to a marriage party on the way they have entered Starbucks. It will never, depict Indian people in casual Western outfits having coffee in Starbucks. This is the bias. Similarly, the Google image search is heavily biased, backed up by deep neural networks. If you search for CEO, it shows all the male CEOs for first 11 rows. At the end of the 11th row, only one female CEO who is a Barbie doll. So this sort of bias towards all minority communities are there in LLMs. We must be extremely careful while generating them. So the need of the hour is responsible AI, which has 3 segments: fairness, giving the outcome of the model, which should be unbiased, do not favor any specific demography or group, especially in medical AI. This is very, very important. Finance AI, banking segment also. Banking softwares are under huge audit in other countries. They need to see whether the bank sanctions loan for specific group or it gives equal opportunity to all the groups. Similarly, interpretability of the AI model, understand the model structure and how it makes decisions directly. The model's input to output mapping should be transparent, but this is very ambitious a goal, because most of the neural networks, they are black box in nature, and that's how they give very good results. If we think that we will be able to break that black box structure, make it transparent, look into its heart, that's very difficult. And explainability, interpretability and explainability are not the same. Explainability means when the model provides a certain outcome from a certain input, like you upload a long X-ray image and your system says this person has pneumonia. Why it is pneumonia? Which portions of the input image are responsible for this diagnosis? That must be marked and explained. That is explainability. Making each decision of the model understandable and transparent. So this is the need of the hour, especially when we try to apply LLMs or similar technologies in a huge country like India, where we have multiple local languages, official languages. So understanding the cultural idioms associated with these different local languages is extremely important, because language is associated with culture. Some phrase may be very, very odd in your language, but very natural in my language. So we must not, uh, you know, uh, use such phrases while talking to each other. Most important thing is the computing ability for any research with large language models, except for minor fine tuning. You need huge computing facility. Usually A500 or this L40S or similar GPUs with huge number of cores, graphic processing units with huge number of cores are necessary. So we must look into neuroscience, how human brain performs huge amount of calculations of the order of 1 exaflop, 10 power 18 floating point operations per second, even by consuming the power of a 10-watt bulb. How human brain does that? Even the best neuroscientists in the world do not understand. They understand about 20% to 30%. We must toil to understand that thing, because that will help us to create mathematical models which could reduce the carbon emission, reduce the power need. DeepSeek is actually one very good step in that direction, which uses a wonderful reinforcement learning structure. So with these few words, I would like to end it up, and thank you very much for your kind attention. If possible, I can take a few quick questions. That's it.
Thank you so much, sir, for enlightening the participants with the current test technology. We are also honored that you took time from your busy schedule to give this presentation. So this is Abhishek. Thank you so much once again, sir.
Thank you, Abhishek, for this opportunity.
Okay, we
Thank
are
you
very
very much.
honored, sir. Sir, here with us, Professor Mihin Mahanti, sir. He want to have some interaction with you, sir.
Sure.
Good morning.
Namaskar. Meet sir.
I have not come. No time.
Yeah, I was under very big time crunch actually. On Monday, I have to fly to Bombay, and till late night yesterday, I was busy in some government level meetings. So that's why, I mean, I'm so much sandwiched. It's almost impossible to come here even for one day. Next time, I will definitely try to catch up with Abhishek, you, and other people from
Otherwise,
this.
we will plan for next somewhere else.
Sure, sure.
Okay, thank you. Thank you very much. I'm
Thank
just
you.
waiting for.
Thank you.
Thank you so much, Professor Swagatam Das, sir. We are immensely grateful for the wealth of knowledge you have shared with us today. Your expertise in deep learning, non-convex optimization, and the evolving landscape of artificial intelligence has provided us with invaluable insights. Your contribution to research and your extensive experience have truly enlightened us. On behalf of the organizing committee of MIDAS 2025, we extend our heartfelt gratitude for taking time to join us and share your profound knowledge. We deeply appreciate your presence and look forward to future collaborations.
Wonderful conference.
Now we will take a 10-minute tea break, and after that, we will reconvene for another insightful talk. So please be back on time to make most of the upcoming session. Thank you.
Professor Celestine.
Hello. Hello, students.
Welcome back, everyone. As we resume our session, we once again extend a warm welcome to all our esteemed guest speakers and participants. We are honored to have a keynote speaker joining us online for this insightful session. It's a privilege to introduce Professor Celestine Ivandi, a distinguished professor of artificial intelligence and the head of Center of Intelligence of Things at the University of Bolton, UK. Before we begin the talk, I would like to take a moment to introduce our esteemed keynote speaker, Professor Celestine Ivandi. Professor Celestine Ivandi is a distinguished professor of artificial intelligence and head of Center of Intelligence of Things at University of Bolton, UK. His expertise lies in IoT security, intelligent systems, and machine learning. With a significant contributions to research and innovation, he is widely recognized in the field. It is truly an honor to have him with us. Now let us welcome Professor Celestine Ivandi to deliver his talk.
Thank you, everyone. Thank you, management, for inviting me. It's an honor to be here today in your conference. Let me share my screen. I hope you can hear me loud and clear, everyone. Can you hear me loud and clear?
Yes, sir.
Okay. All right. It's like I said, the first international conference, there's always the beginning. And the beginning is always what we call the first. The good thing about the first is that sometimes people get relaxed in continuing. But I'm very confident that the Century University and the management will use this as opportunity to aim higher. And very good thanks again to the Department of Computer Science and Engineering. I eventually believe that in our school here, my department, my section, we have lots of Indian. And I think I've been to India 3 weeks also, spending some time in some schools as visiting professor. So I welcome collaboration. A whole lot of you can add me up on LinkedIn, and we can do publication together. We can also do funding together. Okay, back to this topic today. New security mechanism for smart IoT networks. Now, I actually developed this security mechanism 3 weeks ago, and I will show what I mean by that. We call IoT Internet of Things, but people like me call it Intelligent of Things. And also to correct, we have changed our name from University of Bolton, which has been almost 200 years, to University of Greater Manchester. So if you see University of Greater Manchester, you just know that it's the same thing as the University of Bolton. But looking at new security mechanism for smart IoT networks, and she has already read my biography, so there's no need trying to read that again. But let's look at this kind of introduction. Looking at the definition and growth of IoT. The key applications, where do we use them? In smart homes, healthcare. In Bolton here, I'm developing scenarios where IoT is used in our faculty, especially using as artificial intelligence, merging, and doing quite a whole lot, like in psychology, where I develop psychointelligence, a combination of AI, IoT, and psychology. Now, what does it mean? It means we can cure people with dementia. It means we can cure people with mental difficulties. Now, the funny thing about it is we don't need to be a medical doctor to do this. We just need to be computing and AI, and then we can do magic. And that is the beauty about what you are studying today and what you are presenting in this conference. I always believe a presentation in a conference must be a solution to the society. If my paper cannot, someone said, oh, Celestine, your paper, you're highly cited 4 days ago. I said, it's not the problem of being highly cited. The issue is whatever we develop of course, you will get highly cited, which is important as an academician. But you need to make sure that whatever you are developing, whatever you are writing, must be developed. Have you patented your idea? I'm not talking about improve. I created what we call ACRID in my university. ACRID, some of you may have downloaded it, is a system of writing where ACRID, ACROID. A means accept, C means create, R means recreate, I means improve, and D means disprove. Every paper anyone is writing, including all of you in this conference today, falls in these 5 categories. Now, but I emphasize so much to my students the power of creative thinking when it has to do with creating, because our world is in need of creations. Our family is expecting us to be creative. And in fact, the true thing is we're all creative. We all have that star in us to be creative. So it doesn't matter where you have come from. It doesn't matter your color. The last person was talking, I was listening, the last speaker. And when he mentioned that most of the AI are biased, and that is the truth. Most of the things are biased because our people have not come up to be creative in most of these things. So we need to be creative, that women will be recognized. You can see when you said the only CEO that came out from the search was a doll, a woman doll. And that is not right. So that means we have a whole long way to go. In fact, that CEO, there's no black person in that CEO. And we have so many black persons. So that is the bias we are talking about in terms of minority. But are we actually minority? Will I say Indians are minority? No. They're majority. So who is controlling the AI section? Who is controlling the ethical, things that has to do with AI? These are the questions that we ask as AI developers, as IoT experts. And we need to do more so that we can cover up these assertions that, is everywhere. And it shows it belittles us as a country. It belittles us as a people. But we have the integrity, we have the intelligence to make things happen. And how do we apply them to key things? Security challenges. 2011, I developed what I call CIA security. In terms of people were, is it CIA America? I said, no. Confidentiality, integrity, and authentication. How many people mention my name? No. Others took it and developed it as their own. I developed security where you can use the bees to detect weapons in 5 minutes. But then if you Google it, you will see my name in it. So these are all the things we are talking about. Because my PhD was at the University of Aberdeen, was to look at the IoT. I was the first to have to develop and to get a PhD in Internet of Things. Now, but the idea was I developed a security where it will be node-to-node communication and node-to-based communication. It is not just on the network layer, but also on the physical aspect. And I developed it to solve problem in Africa in terms of pipeline detection. How you don't need to be there. Using IoT, we can monitor and protect pipelines because where I came from, we produce oil. But the oil has taken over in terms of the land, so the people don't farm again. So when there is pollution, some people have cancer, so many diseases, and nobody cares. The big companies will come take the oil, and that is it. So I developed something to save the people so that they can know and protect themselves and protect their generation. So we have the definition of IoT. Like I said, you call it Internet of Things. I actually call it intelligence of things. But if we look at your own definition of IoT, we say it's a network of interconnected. They are connected physical devices embedded with sensors, software, and other technologies Now, what do they do? They collect, exchange data over the internet. Now, we move from household items to sophisticated, to military weapons, enabling automation, remote monitoring, and enhanced decision-making. Take with that word, enhanced decision-making. That is where I bring in the AI to it. Now, IoT has experienced rapid change. Initially, when IoT came out, when we were doing the research 2009, we thought it's going to be everywhere. We thought, we have brought in technology, where we can use sensors. But up till now, why have we not realized it? Why are the sensors still expensive? Why are the IoT nodes being still expensive? So, but the goal was to use it in wireless communication, cloud computing, and sensor technology. Now, the number of connected devices we all know are surged. It's everywhere, from smart home, healthcare, agriculture, industrial automation, smart cities. That is what you see. Now, you can imagine the global IoT network, the market, to expand, driven by increasing demand for connected devices every day, from data analytics to artificial intelligence integration. All these are moving up. So, what applications, IoT, have included smart homes, like I said, wearable devices, fitness trackers. We are currently working on big research with football association here in UK, where they wear the fitness of IoT to check their heart rate so that people don't collapse in the field, and to know when somebody will be changed, when the referee blows the whistle, and then there will be a change of persons. Smart cities, when we talk about traffic management, to reduce the traffic, waste management, public safety, then come into what we call industrial IoT, IIoT, where we use it for predictive maintenance, asset tracking and automation. Then you come to healthcare, remote patient monitoring, telemedicine, smart medical devices. Of course, in agriculture, it's massive, massive. Precision farming, smart irrigation, livestock monitoring. Then we have the smart retail, because somebody thinks, no, IoT also functions in finance, where we deal with inventory management, personalized marketing, customer analytics. We have the smart grid and energy. I was trying one time to develop a scenario where you can predict if there will be electricity, if there will be a breakdown of electricity in 2 weeks. Smart meters, trying to use them to take the measurement and take the readings and know how much you generate. And then can we give the power to every home to measure how much electricity they use so that energy can be optimized? And then demand also response. Then we have the automotive transportation, where we have to deal with connected devices, connected vehicles, fleet management, logistic tracking. We have also used it in environmental monitoring, where we check the air quality monitoring, disaster detection, and water management. These are applications of IoT. Now, but if we come down to look at the security, which is my best area, challenges in IoT, we still have the problem of weak authentication and authorization, inadequate user authentication mechanism. We have the problem, very big one, in data privacy, the same way we have in AI, and integrity, risk of data breaches, with what my Chinese people are working now in terms of quantum computing. Nothing will be free from hacking. No password will be safe. So there's a whole lot that is coming in. Now you can imagine a national security and password will be like this to catch because of quantum computing. So many things are coming. Are we prepared for the world that is coming? Which people are using against themselves. Countries are using it against themselves because everybody wants to be a superpower. That is the problem. Everybody wants to control another. But in a world where everything is possible, it shouldn't be a problem. Where we want to live together, it shouldn't be a problem. So it now behoves us, researchers, like you and me, to think out, how do we develop solutions to the problems that humans have created? Insecure communication, you see that? Lack of encryption in data transmission, device vulnerabilities, exploitable firmware and software flaws. That once your software is down, twinkle of an eye, you can be hacked. Scalability, in fact, my password protector, every time, Sister Leslie, your password is hacked, but your password is hacked, change it. And I'm like, for heaven's sake, you have changed password every week, every time. That is how it is. Scalability and device management, where we'll talk about difficulty in managing a large number of devices securely. Are we now looking at the physical security, which I told you we have worked on, which is susceptible to tampering? Lack of standardization. The world gathered in France last 2 months. They still did not agree because America and UK pulled out from standardization of AI. The same problem we have in IoT. That is why the sensor operating in India is different from the one operating in China. The standardization is different operating in America. It's different operating for the one in UK. So standardization is a dream that has not been realized. Inconsistency. Security protocols. Everybody is developing their own because of the fear of the unknown. Now we have the DDoS attack, denial of service, dedicated denial of service attacks and botnets, where IoT devices can be used in large-scale cyber attacks. That is why you have wars everywhere. What do you think they're using? Update and patch management, challenges in securely updating device firmware, supply chain risk, compromised components, or malicious code during manufacturing. These are challenges, and they have come here to stay. But then it requires researchers like you and me to make a difference. Now, common IoT attack, which we call the DDoS, or what some of you will call man-in-the-middle attack, vulnerabilities in IoT devices, why we need AI and ML in cybersecurity. So let's look at it. Distributed denial of service attack, is when IoT devices are compromised, often of a botnet, and they are used to flood the target, a server network, with a whole lot of traffic, overwhelming that the traffic cannot control it. Now, the last speaker was talking about DeepSeek. When DeepSeek came out, they got the kind of attack they have never seen in their life. It was everywhere. Who do you think was attacking them? Their competitors. Their competitors. So people were trained because nobody wants competition. But they forgot to understand that in life, there is no eclipse of the stars. Everybody is meant to shine. I have never seen eclipse of the stars. When I look up in the night and I come out and I look and I tell myself, Celestine, you can be anything you want to be. Look at the stars. I have not seen where two met together. And we have millions, billions of stars. So what is the problem? Everybody can shine. No eclipse of the stars. But that is what we have in our generation. Look at the example of the Mira botnet attack, which leverage insecure IoT devices to disrupt major websites. Why do you think they are disrupted? Why do you think that someone will call you or try to hack your phone and take your money? Then you see the man in the middle attack. Attackers intercept communication between IoT devices. That was why I did security research on security between node to node and node to base station. People attack you between IoT devices, between servers, to eavesdrop because they want to hear. They want to hear what you're saying in your bedroom. They want to hear what your government is saying so that they can find a way to put problem in your hands. They alter. They inject malicious data for their personal gain, for another country's gain. That is what the world is going to. Intercepting unencrypted data from smart home devices to steal sensitive information. Someone told me, Celestine, I don't want to be on the internet. I laughed. I said, you're already on the internet. Once you send an email, you are on the internet. When you use telephone, when you're on the internet, when you send a message. So don't tell me you don't want to be. You're already there. If you're not there, somebody will put your picture and put your biography on the internet. So there's no way of running away from the internet. Oh, let's live like the old days in the Stone Age, where no internet and everybody can be happy. No, is that the problem? It can never happen again. Then you have the malware attacks. Description: malicious software that is installed in IoT devices, enabling unauthorized access, data theft, control over the device functionality, like what you have in IoT ransomware that locks smart devices until a ransom is paid, or spyware that collects sensitive user data. Then they'll send you and say, now I'll block your files. If you don't pay me, you lose. Use Bitcoin to pay. Use that one to pay so that they cannot be traced. A whole lot of mess is going on. These are the common attacks we hear and we see people do. Then the vulnerabilities I've mentioned before in IoT devices, because they are weak. They are small devices. Weak password, making them easy for attackers. Then they lack encryption, because encryption codes cannot be put into the low memory. So it becomes a problem. That's why most IoT nodes or sensors, you see them, there's no security. That is a problem. Then you have the insecure software and firmware. Outdated or poorly maintained firmware can contain exploitable security flaws. Once nothing is updated, you are susceptible to attack. Poor update mechanism, when we talk about limited or no capability for insecure firmware updates, leave devices vulnerable to known threats. And we're talking about physical security risks now, which I've mentioned, where people tamper, leading to data theft and unauthorized control. So what we did in Delta was to generate sensor nodes that could have a 1 kilometer range, monitoring whatever is going on in the pipeline, monitoring people who comes around that place, and signaling to the base station so that we can avoid physical security risk. Now, I've mentioned insufficient data, because insufficient data privacy protection, is inadequate. People collect data, and those data can lead to privacy breaches. People don't care that your picture is there. They use it against you. Once they get hold of what you are doing, they use your medical devices against you. Politicians use it against themselves to campaign. So a whole lot goes on. Inconsistent security standard, which I've said a lot, no company, across IoT manufacturers, there are different standardization practices. What A is doing is different from what B is doing. Why? Because everybody is trying to make sure they make more money. That's the problem. So we need AI and machine learning in cybersecurity. We will need it to advance threat detection. We need it to analyze vast amount of network data, dictating unusual pattern, identifying potential threats and risk. We need it to automate threat response. In other words, it will automatically respond to security incidents, reducing what we call the response time, and also minimizing damage. We need it to be predictive, as a predictive analytics, where you can predict potential vulnerabilities or emerging threats. And how does it do that? Analyze historic data and the pattern of those data. We know very well that attack comes in different patterns, but AI can understand the patterns because it takes a pattern for an attack to be successful. Behavioral analysis, where the MI algorithm can establish baseline behavior for IoT devices and detect the anomalies, helping to identify compromised devices. We talked about using AI to improve accuracy and efficiency. Someone told me, I said, Celestine, I said, yes, what is your problem? He said, I don't like AI. I met a medical doctor. I don't like AI. I said, whoa, what is the problem? He said, AI is going to take my job. I said, no, sir. AI will take the job of those who don't know AI. AI is not there to take your job, but to enhance your capability to do your job better, faster, more efficient, less stressful. AI is not creative. Some of you have been using ChatGPT, DeepSeek, and all kinds of AI tools. It gives you information that is already there. It doesn't create any new one. So creativity lies on human. It cannot be taken away from human. No. So what AI does is to make me remember faster based on historic data, based on information that is either online. And then if you don't want your information to be online because you use ChatGPT, create your own algorithm and call it something GPT. That is yours. So you can create your own. And that is why DeepSeek is there, making it an open source. Like the last speaker was speaking, because I was carefully listening. Create your own and make sure, create for your organization. We work with WTO, World Trade Organization. I develop AI and supply chain. So AI and supply chain, we train them for how many? 12 weeks. And then in Geneva, we did all the things. And they don't want their data to be out there. So everything they do is in WTO. So you can also be a creator, creating things and making money as a company, as an individual, and then succeeding with that. You can create for your university. Every data will be running from your university. Nothing is wrong with that. If you don't want it to be outside, limit, you have the power to create something. And that's why we are here in this conference, to tell you the power you have as a student, as a researcher, to do more than the thinkable. When people say, Celeste, you create so many things every time, I say because it takes one success to be, it takes one art to get to the pinnacle of greatness, but it takes many arts to remain great. In other words, you need to be consistent, or what I call consistently consistent in doing what you are doing. It's not, oh, I'm now a professor. You know, someone said, oh, you're a professor, you don't need to work too much. You know, I woke up 5 a.m. to be in this meeting. And I slept 1 a.m. Because I've never seen anybody who is successful, who works 9 a.m. to 5 p.m. I've never. Those who are successful are those who do what others cannot do. So let me repeat myself. Those who are successful are those who do what others cannot do all the time. Those who do what others can do are easily forgotten. So you have to be creative every day. Every day I wake up, I ask myself, what are you going to create today? I'm not talking of every year, every month, every week, every day. I wake up and say, let's see, what is the goal? Once you put that on you, I'm not talking about competing with others. Like I said, there's no competition in life because stars don't compete. We're all meant to shine. That's why I told you earlier that there is no eclipse of the stars. I've never seen. I've never read. So we need, as students, as researchers, we need to think scalable security solution. What AI can do is massive when it has to do with cybersecurity. Now, we have the anomaly detection. We have what we call supervised, which some of you are researching and presenting in papers here. Supervised, unsupervised learning. I love unsupervised because supervised learning has been, a whole lot of data has been manipulated. So we don't even know what the data can perform. But unsupervised learning gives room for the data to maneuver, to do quite a whole lot that we have limited data to do. Then we have, of course, AI-driven intrusion detection system. Now, let me explain that a little more. In terms of anomaly detection in cybersecurity, we are using it to identify unusual patterns that may indicate security threats. How does it work? AML models learn the normal behavior of system or users and flag deviation as anomalies. We can also use it to compromise devices. It identifies that unusual network traffic or abnormal user activities. You know, we have used label data to classify normal versus abnormal behavior before when we talked about decision trees and SVMs. We have now used unsupervised learning to detect anomalies without label data by clustering normal patterns and identifying outliers, just like what you use in K-means, autoencoders, and isolation forests. We have also used what we call the semi-supervised learning where we look at models trained on normal behavior only and to detect anomalies and deviation from this baseline. Then we have also looked at the supervised learning where these data sets are trained, labeled with known input and output pairs. This, I'm just trying to summarize some of your research that some people are doing. So we're using security for malware detection, where we classify files as benign or malicious. In phishing detection, where we categorize emails as either they are legitimate or fraudulent. Now, what is the challenge there? They require a large label data set, which can be difficult to obtain for emerging threats, especially now that quantum computing is coming. Unsupervised learning, no label data is needed or is used. Now, but what does the model do? The model identifies patterns or group, based on similarities. How do we use it in security? Anomaly detection in network traffic or user behavior, identifying zero-day attacks by spotting unusual pattern. What is the challenge there? High false positive rates, as the model may flag legitimate outliers as anomalies. So there are every problem, and somebody says, every time you bring a solution, there will always be a bigger problem. That is why in your papers that some of you have submitted, there's always what you call future works. Everybody who say my research is finished is dead. There is nothing like finished. Every paper must have a future work. That is the continuity. And others will do. And sometimes your future work may not be done by you. Somebody says, you have a citation. I say, yes, I have a citation. It makes me also to be a creator and never follow the creation up. You say, why? What do you mean by that? I say, my future work is taken immediately my paper is published by others. So even me, one of my paper has 530 something, and it has been downloaded by 300,000 people. And I'm like, some people even download my paper, use my intent without citing me. That is normal, But what I'm saying is, imagine 500 now that cited me. They have used my idea that I said is future work for me. I did not say future work for anybody. Future work for my work. Because when you write a paper, you say future work means something you have not finished, something you want to go on and work on. But people run with it and use your future work as their title. You see, the next week, heading, a paper has been released, and it is your future work. So you can't go now to do the future work, because if you now do it, it will not be as if you are copying somebody else who has done future work. So what do? We create again. So we are what we call a generation of creators. That is what I want you to know as a reader, as someone who is a student listening to me this morning. You are a generation of creators. You don't stop by one. Oh, you have one paper in this conference today, it should be a motivation to do more. Somebody say, Celestine, you came to Bolton 3 years ago, you have 210 publications. And I said, yes, that is even small because I do a whole lot. I'm the head of center, I'm the research coordinator, I have EU conference, I have EU bid, I have so many things I'm running at the same time. I said, if not, I would have gotten more. Because like I told you, it takes one success. It takes one art to get to success, but it takes many art to remain successful. So we have all this coming up. Then we have AI-driven detection, IDIs, where we talk about network-based or host-based. How AI can enhance this IDS, real-time threat detection, where we continuously analyze network traffic for anomalies, or we create behavioral analysis, where we learn human normal behavior patterns to detect deviation. Or we come into adaptive security, where AI models adapt to new attack vectors, evolving threats. These are popular techniques being used for deep learning, where we use neural networks to advance pattern recognition, or you use anomaly detection algorithm, where we identify unusual activities that deviate from established norm. Or you use the NLP, natural language processing, which analyzes log files or security alerts for insight. Now, the good advantage of this is a faster, more accurate threat detection, can be detected. And then secondly, we can also use to reduce false positives compared to traditional rule-based IDS. But the challenges remain, because I keep saying, once you develop a solution, there will be a problem, a bigger problem. I call it new levels, new devils. The more you go, the more you meet different devils. So high computational costs for real-time post-processing. We have the risk of model evasion by sophisticated attackers using adversarial techniques. So let's come down to ML techniques for IoT security. I'm trying to hit some areas so that you see broad what security can do or is in IoT and why we need different things to attack it. Decision trees in terms of random forest, we use it every time. Neural network, deep learning, reinforcement learning for adaptive security, where we look at cybersecurity system, dynamically adapt and improve defense strategies through trial and error learning. That is what we have there. Then we have this one I developed 3 weeks ago. I call it ML-based attack prevention in IoT using the hand defense algorithm or mechanism. Now, I've written papers on ant colony optimization technique. I've developed ant colony optimization because I went to the village and I saw a farm, our end like this. This is AI generated, but this was the scenario I saw. And then the fowl was there. There was no ant gathering the fowl. And then the fowl was incubating 8 eggs. And then we left. In the morning, I came back. The fowl was gone. The hen was gone. And I mean, where is the hen? We saw the eggs. There was no hen. So we traced it. We discovered that the fowl had been attacked overnight by ants. The pieces, including the bones. The pieces, including the bones. So I developed a security mechanism. Now, on what I call ant colony optimization technique, if you Google it, you'll see it there. But 3 weeks ago, I now asked myself, what was the defense? How cruel was the fowl before the fowl died? And that was what led to this security algorithm. So I looked at it. I used Python to analyze it based on AI simulation to protect a hen incubating 8 eggs from ant attacks. And I was able to use the ant movement pattern. And then we came into 3 security the hen can produce. And I compared it later on with the IoT. Pecking. The ants can peck. The hen was pecking the ants that he detected. It uses the wings. So the hen has a wing mechanism. Some of you have seen the hen fight with his wings when he wants to make a defense, or when a vulture or an eagle wants to attack. You see him use the wing. Or when they fight against themselves, they use the wings to sweep them away. So then the other one is releasing natural repellents. Do you know the hen farts? The hen farts. So that is what we call natural repellents, simulating protective action. In my village, when the hen farts, it runs. It will run. So when you see the hen suddenly run, my people then calls it that the hen has farts. They speak it more in my language. But when I started doing research, I discovered that it is actually a security mechanism for the hen to run away from impending attackers. Now, I use AI-based decision making. The hen chooses the best protection method based on the number and position of the ants. So, AI-based ant detection and response system, simulation of the hen's defense strategies, and multiple prevention mechanisms. So I developed the code, worked on it. I told my students to work on it, and they did that. We did so many things. And how does it work? The hen detects approaching ants randomly. Now, you see, this is biological sensitive security protection. It's just like the bees, the honeybees that we develop, that we use, because the bees is more sensitive than the dogs. And it takes us 10 minutes to detect, 5 to 10 minutes to detect, then when I worked, the home office were giving us drugs and everything. So it takes us 5 to 10 minutes to train the bees, and we release it in our, vessel. And then the vessel, we can use it to know whether you are carrying drugs or you are carrying a weapon. The bees is so powerful. Now, the project stopped because it was sponsored by Home Office. It stopped because they felt we were killing the bees. No, we were not killing the bees. We were sending the bees back to the hives. I'm a believer that COVID is a product of the lab because I worked in the lab. So when you release the bees back to the hives, it becomes more dangerous than when, because we have used all kinds of things on the bees. The bees become more dangerous than normal bees. And if it sting you, there's no cure. So, but the hen, like I said, develop its own security. When there are 1 to 3 ants, when there are 4 to 6 ants, when there are 7 to 8 ants, when there are 9 to 10 ants, it calls for backup. Have you seen a collection of hen chickens? You see them making noise. What do you think they are doing? They see danger. Maybe they have seen a snake coming into their abode, or they have seen something that they cannot defend. They are calling for backup. So, and I run this system multiple cycles, simulating real world defense mechanism. And then we were able to look at it like one day, out of which there are 2,000 defensive barricades. So I developed the security mechanism, which my students are working on to publish now, And then we did quite a whole lot inside it. But I wanted to come into how I converted it into a smart IoT network. How I was able to put the similarities together. IoT integration, machine learning model, automated sprinkler system, and how we're able to come up to this diagram, where I developed threat classification, continuous learning, MI-based threat detection, feature extraction, data collection, and I was able to have an MI-based defense workflow from the hand optimization mechanism that was developed. And then you can compare it. Hand defense, IoT security complication or implementation, pecking ants, blocking malicious IPS, flapping wings, rate limiting to or traffic filtering, releasing repellent, AI-driven malware scanning and isolation, calling for backup, automated security alert for admin, creating barricades, and then you have automated security alert, and then you have simulating rain, AI based on the comps of full system lockdown. So we're able to do this. And at the end, I developed AI-powered attack prevention for smart IoT network, from hand defense to IoT cyber security. So that is what we have there. I ran it again, the different way, data processing, do the normal thing we do, and then came up with what it can do. Then we look at the AI ethics concern, look at the privacy concern, AI bias and unintended concern. How does it react? I was checking online. Then I also checked the legal and the AI ethics implication of the end defense mechanism in AI-powered security system. I ensure oversight, implement human oversight, data privacy and security, reduce bias in AI models. And then that's how we got it. So what is the goal in the future? Edge for AI for IoT security, where we think of edge AI processes security data locally on IoT database, reducing latency and improving real-time defenses. So this is what we have, and thank you very much. That's the end of my presentation.
Thank you.
Thank you, Professor Celestine Ivandi, for your insightful and thought-provoking session on new security mechanism for IoT. Your expertise and valuable perspective on AI-driven security solutions have certainly enriched our understanding of this invoking field. We truly appreciate the time and effort you have taken to share your knowledge with us today. On behalf of the MIDAS 2025 organizing team and all attendees, we extend our heartfelt gratitude for inspiring thought. Thank you, sir.
Thank you.
We now have reached the lunch break. We invite all esteemed guest speakers and participants to proceed for the lunch. After the lunch break, we will resume with another exciting session of talks. So please be back on time. We look forward for your participation in the upcoming sessions. Thank you.
So all of you come back and join the workshop session by Springer editor Neha Sharma, and that session will start sharp at 2:30. Okay, that will be of 1 hour session. After that, we'll have one tea break. Okay, so all of you come to the auditorium once again, sharp at 2:30. Yeah, you